So text pre-processing is one of the first step that we do in NLP. And in text pre-processing, we pre-process the text so that it can be fed into the model for training. And in pre-processing, there are various steps, mainly text cleaning, text normalization, and text tokenizations. So we'll go through them, each of them one by one. So let's first look into text cleaning. So in text cleaning, we convert the text into a simpler format by performing some text-based transformations. So we'll look into each of the transformations one by one. So one of the important libraries in the NLP is NLTK, which is uh, which is Natural Language Toolkit. It contains various functions related to NLP. And Beautiful Soup 4 is one another library which we required for parsing HTML content. So let's install those libraries first. After installing the libraries, we'll import the libraries module, sorry, we'll import the modules RE and string. So the RE module is for regular expression and the string module is for performing any kind of uh, string related functions. So let's import the modules. Let's look into the first transformation, the lowercasing. So given a text, it contains capitalized letters. It might contains word where all the characters or all the letters are in capital form. So lowercasing will convert everything, all the characters from the text into a lowercase format. It becomes slightly easier to process because we don't have for the same word we might have different version, right? So let's first run this. So this sentence, this is a mixed case sentence. So this sentence after transforming, it got sorry, so, yeah, sorry. So it got transformed into lowercase. As you can see, all the characters in this sentence are in lowercase. Why we need to do this? Because this word, okay, this can be written in multiple uh, format. So here we have the capital T, here we have a small t. Even we can have all the letters in capital format. So So for the same letter, sorry, same word, we are having three different representations. So to remove them, what we can do is we can convert everything into a common format. So we are converting everything into lowercase. Okay. The next thing is remove HTML tags. So when we scrape the internet, when we are getting data from the internet by scraping, we'll have HTML tags. So but the HTML tags are not very important for model building. So to remove the HTML tags, we have this beautiful soup libraries. So which we installed earlier. So we are importing the beautiful soup library, and so this is a HTML text where we have paragraph tag and then bold tag. Okay. So as you can see, it's not readable even for us, and for machine learning model, it will make it slightly complex. Okay. So to remove this, we are just using this library. We are initializing it with the text, and then we are saying that get the text from this HTML content. So once we run this, sorry, I forgot to run this. Okay, once we run this, you can see we're getting a clean version of the HTML content. So it's much easier for to uh, read for us as well. Okay. Next thing is to remove URLs. So the URLs which are present in text might not be very useful. So what we do is we remove them as well. And to remove the URLs, we are using the regular expression library. So this is a regular expression which will remove anything which start with HTTP or HTTPS or www. So if you run this, so here we have checked this out example and then a URL. So if you run this, as you can see, we are getting rid of this URL. We are only having the text content. Okay, so let's look into the next technique to remove the special characters and emojis. So by special characters, I mean the non-ASCII characters. So we can remove the emojis and non-ASCII characters using regular expression. So here you can see we have this regular expression to remove those. If you run this, you'll see that from the text we have removed the emojis. Next thing is removing punctuation marks. So given a text, we have we'll have punctuation marks obviously. So the punctuation marks in some cases might not be very useful for model building. So you can remove them using this technique. Here we are using text.translate. This is inbuilt in Python. So you can run this function, okay, from text. So I mean, from this is coming from the string only. Okay, so you can run this function, and then you'll see that we have removed the punctuation marks. You can also create regular expressions for this, but this is also inbuilt. So we have this string that punctuation inbuilt. So it will remove the punctuation marks. And then the next thing is the numbers. So numbers might not be very useful in model building. In some cases, in that case, we can remove the numbers. So here we have this text. This video has 4,518 likes. So we want to remove the number. So we can use the regular expression library. So here basically it will remove any number from the text. Okay. So as you can see, we have removed the number from this text. Then we have stop words. So in in any language we'll have stop words. So in English we have stop words. So the stop words are the words which are not very useful. So the words like this, is, of, a. So these words are not very useful in the sentence. So to remove the stop words, we'll need to use the analytical library. From analytical library, we need to download the stop words. Okay. Once we download the stop words, we can basically loop through each of the word from the text and remove them. And here we are looping through each of the word present in the text by splitting them with spaces. If the word the lower is not in stop words, if it's not present in stop word, then we are keeping it, otherwise we are removing it. Okay, so once we run this, all the stop word will be removed. So the original text is, this is an example of stop word removal. After removing the stop word, we are left with example stop word removal. So this is an, of, a are removed from this text because those are stop words. You can also create your own stop words. You can also extend this list of stop words based on your need. Okay, so let's see what we have in stop words. Sorry. So these are the list of stop words present in the analytical library. So words like the, there, them, then, to, up, was, which, who, why, you, whom. All of these are stop words. You can extend this stop words based on your need, or you can also remove some words from here. For example, the word not is here, okay, not or not. If you remove not from a sentence, then the meaning might change. So in some cases, you'll find that people remove this not from the stop words, or they may even create their own stop words based on the needs, okay, based on the project need. So let's put everything together. So we have created this function where we have put everything. in one place. Okay, so we are doing all of the steps mentioned above. So once we run this, okay, let's run this. You'll see that from this sentence where we have visit our site at this in 2023, it's awesome and free, and we have emojis and everything. This becomes visit site awesome free. Okay? And as you can see, we have removed lots of complexities from this sentence. And now it will be much easier for the model because we have removed lots of complexities. Okay. The text normalization in NLP is technique to convert the word into its base form or root form. So in uh, in English or in any other language as well, you'll modify the word to express different grammatical categories or grammatical functions. So let's look at this word go, right? So in past simple form it's went, in past participle form it's gone, and then in continuous is going, and goes uh, is another form of go. Okay, so there are five different representation of go. Okay, for the same word we are having five different representations. So for one word we are having multiple representation. To reduce this word inflections, to reduce this number of different unique words, what we do is we convert the word into its root or base form. Okay, so for text normalization, we have two techniques. One is stemming and another one is lemmatization. We use either one of them. So in stemming, we reduce the word to its root form, often by chopping of the suffixes. So by suffix, the characters at the end are chopped off to get the root word. And often what happens is that when we chop up the characters, the word we get is not a dictionary based word. Okay, so whatever word we get, it might not be present in dictionary. So let's see an example. Uh, okay, so for go, the root word is go. For went, it's went only. Okay, for gone is gone. For going is go. For goes is GOE. Similarly, so see, this is a not non-dictionary word. Okay? This word is won't be in dictionary. Okay? So similarly, flies is FLI flee, happily we see this. So we are converting this for each of the word, we are converting them into its root form. And the root form what might or might not be present in dictionary. So here in studies, we are chopping off the ES to get study with I. Similarly, in argued, we are chopping up ED to get argo. Okay, so this is a portage termer. Is present in analytic library. You can import it, and basically here we are going through each of the word and then stemming it. There are other stemmers also available, but portage stemmer is one of the popular one. Yeah, so here we convert it to root form, but root form might or might not be a dictionary based word. So to get the dictionary based word, because in some cases you might want the dictionary form, okay, dictionary based form. So we can use the lemmatization technique. So in lemmatization, what we get is the base form which is present in dictionary. Okay, so let's download the WordNet lemmatizer from NLTK, and when you run this, okay, here we are lemmatizing. So you are saying go is go, okay, went is converted to go, gone is again converted to go, going is converted to go, goes is converted to go. So all of them are converted to go. Okay. Then flies, right? Flies is inflection of fly. So it's converted to fly. So now this fly is present in dictionary. Okay. Similarly, happily. Okay. Happily converted to happily only. And then studies is converted to study with Y. So this study is present in dictionary. Similarly, you can see for faster and argued. Okay. So the difference is here we are just chopping off the uh, suffixes. Here we are using some technique to get to the dictionary-based form of the word. Okay. So if you see the code here for limitizer, we're calling the limitize function. We're passing the word, and we are having this POS parameter. PO is for part of speech. Okay. V is for verb, and you can have adjective, noun, A for adjective, N for noun, and so on. So here what we are saying, this word is a verb, and consider this word as a verb, and then get the lemmatized version or get the lemma of this word. So that's why you are saying the for different form of the go, we are getting the lemma go. Okay. Uh, if you think some word is not a verb, it's adjective, you can use a for adjective. So we should use either one of them. Stemming is slightly faster than lemmatization, and if you are, you can use stemming if you don't need the word a dictionary based form, you can directly use the stemming. If you need the dictionary based form, then you can use the lemmatization. So both of them are available in analytical library. So we should not use both of them. We should use either one of them because both of them are doing the same thing. Tokenization is one of the important steps of NLP. In tokenization, we transform the text into smaller chunks so that it can be processed. And the smaller chunks are called tokens. We convert text into tokens. So there are different techniques for tokenizations, and we usually use one of them based on our need. So let's look into the first one, the character tokenization. It's not generally used. It can be used in tasks like OCR, like reading text from images. So basically, what happens is that given a text, each character are separated. Okay, so given this hello with exclamation mark, each character are separated. Then we have the word tokenization, which is mostly used in NLP tasks and traditional NLP machine learning techniques. So for this to word tokenization, punctuation library from NLTK. So you need to download this punct and punct tab from NLTK, and then you can use the word tokenizer. Okay, so we have downloaded this. We have imported the word tokenize, and when you have a sentence like "Hello world, how it's going," and you pass through the word tokenize function, and then you'll see that each of the word are separated. So hello world, how it's going. So each of them are separated. And even the exclamation mark, punctuation marks are separated individually. Okay, so here we are having exclamation mark, and from house we are having how and apostrophe s separately. Similarly, the question mark is also separated. So each of the word and each of the characters from punctuations are separated. So this is the word tokenization is mostly used in traditional machine learning techniques. Then we have the subword tokenization. Basically, what happens is that instead of each word, we are focused on subword because there can be very huge number of unique words. So to reduce this count, the number of unique words count, we can use subword tokenization. So basically, it breaks down the complex words into smaller words. Okay. So these are mostly used in transformer-based techniques. So if you are using any kind of LLM, internally the LLM is using the subword tokenization. So Uh, let's look into one of the subword tokenization. This is from the BERT tokenizer. Okay, uh, we are getting the BERT tokenizer from transformer library, and we have this word, okay, misspelling. Once we tokenize this, you see that miss is a separate token, and then PEL is a separate token, and then LING is a separate token. So this helps in reducing the number of different unique words, because this LING or this PEL can be part of other words as well. Okay, so this is a technique to reduce the number of different unique words, where if you use the word tokenization, you'll have a lot of different unique words. Then we have the sentence tokenization. It's also not used much, and basically, as you can guess from the name, we are converting each of the sentence given in a paragraph into a token. So each of the sentence will be token. We have downloaded the function library, and then we are importing the sentence tokenizer. Okay, we have this paragraph. Hello there, how are you doing? I hope we are learning uh, NLP. It's fun and useful. So we are having multiple sentence in this paragraph. Once we do the sentence tokenization, you'll see that each of the sentence are separated. Okay, we have four sentence here. It's not useful. It's not used much in the traditional NLP techniques, but it's also one of the tokenization techniques. So these are the four main tokenization techniques available in NLP. Thanks for watching.